Okay, a lot of you are familiar with this, whether we started chapter 5, then chapter 6, then chapter 9. Now, out of this author's edition, it's probably chapter 12 in your edition, but from the content that this is based off of is from an earlier edition that was chapter 11. Regardless, it's still arthropods. What might be, or what comes to mind when you see arthropods? Okay, spiders are arthropods. Centipedes are arthropods. Beetles, yep. Okay, so crickets, what did you say? Oh, you didn't say anything, okay. Now, with all those examples that we heard, I remember spiders, I heard centipedes, I heard beetles and crickets, okay? Classification purposes, are they all in the same phylum? I see no. Or is it yes? Yes, because they are all arthropods. Okay? Are they in the same class, do you think? No, because, okay, beetles, crickets are in the same class. Okay? Would they be in the same class as spiders? No, they are not. And just from what you possibly remember from biology, what might be two of the, well, especially one big reason, and it has nothing to do with food gathering. What might be one big reason why those animals are not in the same class? Okay, so when we talk about legs, what is the difference between the two? Okay, so insects have 6 walking legs where, okay, do all spiders have 8 then? Yes, yes they do. Okay, can you think of another animal that might be in the same class as spiders? So now you can think of envenomation, but that's a tricky question. Because there's I don't know if you want to say a select few, but when it comes to arthropods, there are venomous relations to that of spiders. Okay, scorpions is one, and then your centipede is another. Those are also venomous. Now, are they dangerous to humans? Not really. I mean, all spiders are venomous, though. Okay, that I think we could agree upon. But are all spiders dangerous? No, not unless you might be allergic to their venom. But there's no way that you would know that unless you were envenomated by one and then had a type of toxicology screen, perhaps, just to see if you are perhaps allergic to them. That's what I'm trying to say. And then going back to that first question, okay, so how would you know the difference between a spider and an insect? It's going to be their body segments is another one, okay? Because that's when we get down the line, insects got 3, spiders and scorpions only have 2. Okay, so why are these animals so successful? Okay, well, there's going to be a whole list of options that we could go through. And when we look at the schedule, it just says begin chapter 11. Okay? And then on the next day, it just says success. Are we going to get through all of these? Maybe, maybe not. But to begin with all arthropods, okay, why are they so successful? Well, they've got this exoskeleton that, of course, does a type of protective function. Okay. Of everything that we see here up on this slide, we're doing some abstract thought or abstract thinking, which means, okay, you have to apply this knowledge in one aspect of these animals and apply it to another. What do we see up here that would apply to humans? Why are you right when you said cuticle? That's true. What is it about this that could possibly apply to humans? Where is a human's cuticle? I mean, I bite mine all the time. Say that again. Fingernails. What? Okay. But fingernail biter? Okay. No. Oh, I'm sorry. No. So.
You said you bite your cuticle though. Are you like gnawing at it? Like on there?
No, I said, didn't I say nail? I said we bite ours, and I meant nail when I said that.
I suppose.
Okay. So would people say, what's wrong with us? So do you have lots of, when you're tearing your fingernails out, is there lots of bleeding on there or no?
No, I usually don't go that far.
Okay. So I don't know how some people can do it, but they'll actually tear parts of like half their fingernail off, but then the underlying tissue is unaffected. It's just a short nail. I don't know how or why they'd want to do that. To me, it's not nervousness. Is it just habit?
I do it when I'm nervous,
Oh, okay.
but yeah, habit.
Mm-hmm. Or maybe we're distraught, we're angry because got this class right now. Maybe not. I don't know. I was mimicking biting my fingernails for those tuning in at a later time. Okay, but yes. Okay, so in this case, when it comes to arthropods, as an outer covering, just like what we have with our fingernails, there's an underlying tissue or epidermis. Okay, now this is a trick question. Are these animals fairly advanced? Because that should be a two-part question. Are they really advanced? No. Are they really advanced for an invertebrate? Well, then I think everyone would agree, you would say yes. Because, or else why would we say, why are these animals so successful? Okay? Well, one of the things to keep in mind, they have this shield that they can carry around with them all the time. And that's hard to visualize when you think of that of insects, okay? How is it that they have, it's going to be the amount of this substance that's going to vary from one arthropod to another, okay? When anyone who's spent time outside this summer, I thought it was rather odd. Usually a type of sound that you might hear outside when it's getting close to sunset is that sound where you hear yeah, you're nodding your head, that's cicadas. Typically, I think that's something that I would always associate with maybe late July at the earliest, if not August. But I was under the impression, I thought I heard them in June already. And I don't know how or why that is, but with that type of an insect, okay, which is very large, okay, you compare that to a housefly, they're certainly going to have more of this chitin in there. Because for anyone who's ever, of course, swatted at a fly with their two hands, draw them together like you clap, okay? I'm not very good at that, but sometimes I will smash one between my hands and you go, oh geez, I got some of the blood and their other underlying tissue on my hands. How would that be possible if they have this protective shell? Well, a good question, but my interpretation is they just don't have a lot of it. Why might a fly not have much of this? It's not so much their wings. It's you're not far off. The more protein that you add for this, what's going to happen? It's going to be harder for them to do what? Not just move, but it's going to be harder for them to fly, actually. They're just going to be too heavy. Okay? So with that, then when you look at other types of insects that you have that crawl along the ground, okay, grasshoppers, your crickets, beetles, was it? Okay, I don't know about the classification, but if a cicada is a type of beetle, maybe it is. I'm not an entomologist, but I certainly would think the amount of chitin within each one of these animals is going to vary, and the more you have in it, of course, the more heavy it would be. So, with all arthropods that you have not named yet, who would probably have the most chitin in their body? So you got to think it can't be so much that it would be hard for them to move. So you'd have to go aquatic then. Who might be an arthropod then that has a large amount of chitin in their body? Okay, crustaceans. Okay, and that would be like horseshoe crabs would be one. Okay, king crabs, lobsters. All of them would have a large amount of chitin because they have such a tough, rigid exoskeleton. So anytime you think skeleton, you think of framework, which would be right, but then that's probably not the first thing that comes to mind. What comes to mind when you see skeleton? Okay, yeah, Halloween, yeah, bones too, but is it on the inside or the outside? Okay. Yeah, but in this case, yeah, if you're talking about humans, yeah, or mammals or any type of vertebrate, yes, then it's on the inside. I didn't quite ask that question yet, but regardless, when we think skeleton, it's probably a protection more than anything else. Okay. So, oops, I don't know what happened there. Did I hold it down? Did I? Okay, we got gremlins in here or something. Okay, let me go. I don't know what's going on here. Okay, there we go. One of these times I am going to remember that spray to put on these hinges. So it just hasn't been lately. Okay. So when we get through these keys, there's actually going to be 6 of them. So an exoskeleton is certainly going to be an advantage. One, there's actually, I think, 3 reasons why it's an advantage having this exoskeleton. One and foremost is protection. I would think when we think of any type of skeleton, yes, it's going to have a protective function, whether it's on the outside or whether it's on the inside. Now, with mammals and humans, besides protection, what might another function of your skeletal system be and or do? For those of you, we have talked about this in biology and we've talked about it in A&P as well. What are some other functions of your skeletal system besides protection? Do we remember? Okay, so movement is correct, but I don't say but. Movement is right, but what's actually causing the movement? Because it's the muscles, there has to be a place of attachment. So when you say movement, that's right, and because there's a place for attachment of these muscles. And that's what we're talking about here. That's segmentation and appendages. So when we think of this type of movement, yes, muscles will attach to this type of skeleton. Okay? So your elbow is a type of hinge joint. Okay? If that was not segmented or you did not have a joint there, try to scratch your head. If there's no joint here, you can't scratch your head, can you? Well, you can rub your arm against there, but because you have segmentation or a joint, that's what the segmentation means, that you can bend your elbow, bend your wrist, and then scratch your head. When you get bald like myself, tends to be a little more frequent, put it that way. Maybe it's because I just think too much, because there's a lot going on in this noggin of mine. Yeah. In other words, if you're telekinetic, I don't know if it's finalized, but Minnesota, did they sign a quarterback from Arizona? I think so. So that's probably not the most important thing to be talking about at this time, but it is Vikings. It is pretty important, isn't it? Yeah. Because holy cow, to start 0-3, now they're playing 500, so at 4-4, that's quite an improvement. Okay. So these jointed appendages, okay? What happens it creates these levers, and they're moved by muscles. These muscles have to have something to attach to. What do they attach? The exoskeleton. Okay? Then that's a very vague term. Okay? Probably only individuals that have had anatomy and physiology would know what that possibly even means. What is that striation referring to? Because there's cardiac of these, there's smooth of these, and then there's striated of these. What might they have in common? Those are all muscles. Striated muscle is just that. It's got striations in it. Okay? And then smooth muscle, like what you have in your glands that cause muscles to secrete. You also have them in your skin, but most importantly in your intestines. Okay, that just contracts on its own. There are no striations in there. That's why it's called smooth muscle. Then finally, the only place you would find the last portion or third part of muscle tissue, of course, is in your heart. It's cardiac tissue. All right, so we've seen two reasons why arthropods are so successful. They've got these joints, okay, just like we said, on your elbows, wrist, fingers. Those are examples of joints inside of us, okay? And it has to be on an appendage, okay? Our arms and our legs, those are appendages, so we also have jointed appendages. Then probably one of the most significant of these is they don't have to worry about respiration, okay? Because it's piped directly to their cells, okay? I guess I kind of skipped these two, but this is kind of referring to, okay, these jointed appendages are equipped with sensory hairs, okay? That's not just unique to some arthropods as opposed to others, okay? Because it's really, really difficult to take your hand, and there's a fly on that textbook, to take your hand and swat down on it, okay? And perhaps in biology we have discussed, why is that even possible? The insect, it probably can't see your hand, okay? It can't smell you, okay? And it really doesn't have that big of a brain, not for thinking, but there's something that causes them to be able to move out of the way, and it's somewhere up here. So what's significant about their hairs? So what happens is anytime you have air movement, especially in a direction like down on that textbook, there's going to be air currents that are forced down where they're at. So they sense, of course, that air movement coming down. They feel it in their hairs, and away they go. So that's why we say these hairs are modified sensory organs. For us, it's just usually what we can feel all throughout our skin, on our fingertips, okay? Our nervous system is obviously quite more complex than what these animals are. Yes. So when we see this term, this air is piped directly to their cells, okay? It says most land arthropods contain this highly efficient tracheal system. That's what it says. Most, not all, okay? Because in certain cases, when we picture that of spiders, okay, those have what we refer to as book lungs, okay? So what that means is underneath their abdomen, okay, is where they have this oxygen that just goes right into their body. But with most land arthropods, a lot of the insects have this tracheal system, okay? And oddly enough, where do you think insects like flies, where do they get their air from? Well, of course we could say, well, from the atmosphere. Yes, that's true. But what on their body will supply their oxygen demands when we're talking about this? Because when we think of insects, we think of what they can do, which is what? Majority insects can do what? Like I said, not all insects, but the vast majority of insects can do what? Someone probably said it. Just guess. Yeah, so they can fly. So they've got these tracheal tubes. They're actually in their wings. Okay? So what happens is, and I don't know how accurate that is, if you caught a live fly, pulled their wings off, or is that really going to suffocate them? Well, maybe. But if you look really, really close, you'd have to magnify that. There is what we call veins, not for carrying blood, but these, I think they would be called veins, these tubes that are going through their wings. That is a type of tracheal system. Because when we think trachea in human terms, it's right here. It's in your neck. That's what goes down into your lungs. So it has to be tied to respiration. And that's what we're talking about here. Okay, I think one more, and we're going to stop once we get to there. Okay? So this air is piped directly to their cells, so it comes into this tracheal system. And then it's not pumped through blood. It doesn't have to, because it has these tracheal tubes inside of them. Kind of like a ventilation system would be a good way of visualizing that. Okay, that's where we're going to stop. We're going to start talking about their sense/sensory organs tomorrow, and then we will continue on. Of course, we don't have an exam. That says Chapter 9. We're past Chapter 9. We're into Chapter 11. So we will pick up with this next time. You've had some time now, Mr. Wagner. Can you? I'm going to stand out of the frame. It's. Yeah. Do the same. I would maybe get Stuart there.
Stu?
Yeah, get Stuart. Play a song. I mean, just press his button and then hit it again. See, then you just
There we
bob
go.
your head, and there you go. So that's where we say we'll catch up to you next time.